Okay, here we go. We've got another proving an identity question. Okay, and then having proved that, okay, we've got to do this. Now this is a piece of bookwork. This is one of the identities, or closely related to one of the identities that you need to have learned. But we've got to prove it starting from this. So you need to think about how you turn something that has sine squared theta and cos squared theta and 1 in it into something that has these things in it. And you're going to be dividing by something. So you might want to think about what the definition of cosec squared theta is, or cosec theta, and what cot theta is when you express it in terms of sines and cosses. And that should give you a pretty good idea of what you need to divide this equation by to get this one. So that should be 2 easy marks. And then, much cleverer, is this, okay? Now here, these things are both squared, and these things are to the power 4. And something to the power 4 is that same something squared again. Does that make sense? What I'm talking about is that you probably need to view this as being of the form a to the power of 4 minus b to the power of 4. Actually, not as a to the power of 4 minus b to the power of 4, because it would be c squared minus d squared if only c, if c was a squared and d was b squared. Okay, then b to the power 4 is d squared, and c to the power a to the power 4 is c squared. So this is sort of maybe more suggestive, and you know a way of factorizing that. So factorize, it's called, this is a difference of two squares patterns, yeah, but it looks like the difference of 2/4 powers. So if you take something that's effectively the difference of two squares and factorize using your normal factorization for something that looks like something squared minus a square number, then you'll discover that wonderful things happen, and that you will be able to apply this result from part A. So a bit sneaky that, but if you follow this advice, if you get the hint, then you might be able to get your 2 marks. Hope so.